Welcome mathematicians. In today's video we'll be looking at normal distributions and example problem solving. So here we have our normal distribution graph centered around the mean and going up in increments of the standard deviation and also going down in increments of the standard deviation with the relevant percentages allocated. So let's look at using this graph to solve some problems. Example number 1. The time taken to travel between two regional cities is approximately normally distributed, with a mean of 70 minutes and a standard deviation of 2 minutes. What is the percentage of travel times that are between 66 minutes and 72 minutes? So first of all, we can see in this question, it has the words normally distributed. So we can use this particular diagram to answer this question. Next, it says that the mean time for the travel between two regional cities is 70 minutes. So on the base of our graph, we've got the labeling, time in minutes, and we can place 70 along the representation of the mean. Next, we're told that there's a standard deviation of 2 minutes. So along the base of our axes, we're going to first of all go to the right, adding on 2 minutes for each interval. At the end of the first division, this first line, we have a time of 72 minutes. End of the second line, we have 74, and the third we have 76. So we're just incrementing our time scale by a standard deviation of 2. Likewise, we can go to the left. This time we're taking away 2, so we go from 70 to 68 to 66 and 64. And the question being asked is, what is the percentage of travel times that are between 66 minutes and 72 minutes? So let's identify these two times, 66 on our axes and 72. So between 66 minutes and 72 minutes, we have this region covered in red. And the total percentage is just the sum of these individual sections. So it's 13.5 plus 34 plus 34 a second time. That represents 81.5% of the total distribution. Example number 2. The volume of a cup of soup served by a machine is normally distributed with a mean of 240 ml and a standard deviation of 5 ml. A fast food store uses this machine to serve 160 cups of soup. What number of these cups of soup are expected to contain less than 230 ml? So the key term is normally distributed. Again, that means that we can use this normal distribution graph. We're advised the mean volume of the soup cup is 240 ml. So cups of soup, the mean in the middle is 240. We're also informed that the standard deviation of this distribution is 5 ml. So we go across one interval and add a standard deviation for 245. We go across another standard deviation for 250 and another standard deviation for 255. That's adding on a standard deviation each interval to the right, increasing from 240 all the way through to 255. We then subtract a standard deviation of 5 from the 240 to 235, and a further subtraction of 5 for 230, and a final subtraction of 5 for 3 standard deviations being removed from the mean for 225. We now have all the information required to solve this problem. What number of these cups of soup are expected to contain less than 230 ml? 230 ml on our graph is this point here, 230 ml. It represents everything on the distribution less than this particular division of 230. We add these two percentages up and we end up with 2.35 plus 0.15, giving us a total of 2.5%. So our first step was to find the percentage of cups that have a volume less than 230 ml, and it is 2.5% of the entire distribution. Please note, this question doesn't ask what is the percentage of cups with a volume less than 230 ml. Rather, it says what is the number of these cups of soup are expected to contain less than 230 ml. So step 2 is to find the number of cups with a volume less than 230 ml. So the number of cups with a volume less than 230 ml is 2.5%, or rather 2.5 out of 100, multiplied by the total cup number of 160. And when we perform that calculation, we end up with 4 cups. So what number of cups of soup are expected to contain less than 230 ml from this distribution? The answer is 4 cups. Example number 3. The pulse rates of a population of Year 12 students are approximately normally distributed, with a mean of 69 beats per minute and a standard deviation of 4 beats per minute. A sample of 200 students was selected at random from this population. Calculate the number of these students with a pulse rate of less than 61 beats per minute or greater than 73 beats per minute. Again, we've identified that this is a normally distributed distribution. So we can use this particular graph to answer our question. Again, we're identifying that there is a mean of 69 beats per minute. So on our beats per minute scale, 69 is our mean. Here's our X bar. It represents the mean of our sample. There's also a standard deviation of 4. So first of all, we're going to add one standard deviation to our mean. Adding 4 to 69 gives us 73. We're then going to add a further standard deviation of 4, which gives us 77. And finally, yet another standard deviation of 4, which gives us a value of 81. We now go to the left of our mean value. 69 minus a standard deviation of 4 gives us 65, minus another standard deviation of 4 gives us 61, minus a final standard deviation of 4 gives us a value of 57. So we now have our x-axis set up to answer this question. We want to calculate the number of people with a pulse rate less than 61 beats per minute or greater than 73 beats per minute. So let's identify those positions on our graph. 61 is here, 73 is here. So the first group of people were less than 61 beats per minute here, and the second group of people was greater than 73 beats per minute. So we can tally up these individual percentages, that is less than 61 beats per minute or greater than 73 beats per minute. So step 1, find the percentage of people with a pulse rate less than 61 and greater than 73 beats per minute. And here we have it. It's the 2.35 plus the 0.15%, plus a further 13.5, 2.35, and 0.15%. In total, that represents 18.5% of the population. Again, this question doesn't say find the percentage of people with pulse rates less than 61 beats per minute or greater than 73 beats per minute. It wants rather the number of people. So step 2, to find the number of people with a pulse rate less than 61 and greater than 73, we take that percentage of 18.5, divide it by 100, and then multiply that by 200. That represents 37 people out of a sample of 200 that have a pulse rate less than 61 beats per minute or greater than 73 beats per minute. Thank you for watching this video. If you've enjoyed and indeed learned something from this video, please remember to like, share, comment, and subscribe. And as always, thanks for watching.